Today's lesson will be on segment and angle bisectors. We'll look at bisecting a segment and applying this to a basic problem for solving, bisecting an angle and applying that as well to a basic problem in solving. Why do we learn about these? Examples would be folding for congruent shapes and applications such as a strike zone in a baseball game and the hockey puck on the sideboards that use these concepts. A segment bisector can be a point, a segment, a ray, a line, or a plane that divides a segment into two equal or congruent parts. If it happens to be a point, the point is called the midpoint. An example here is the midpoint. Notice that we have two ways to write it. Either the segments are congruent using our congruent symbol, or we say that their measures are equal. We can also have a line, a ray, or a plane bisecting a segment. This is an example of line LM bisecting the segment into two equal parts. An angle bisector is a ray that divides an angle into two adjacent angles that are congruent or equal. As you can see here, we have ray DB bisecting angle ADC. One use of finding a midpoint is using the midpoint formula. We use it to find the midpoint in a 2D coordinate plane. Similar to what we did with distance formula, we assign a point to be the first x and y. We assign a point to be the second x and the second y. To find the midpoint, the M stands for midpoint. In the subscript, we can add the two x coordinates and divide by 2. To find the y midpoint coordinate, we can add the two y coordinate values for the endpoints and divide by 2. We're going to find the midpoint of segment DE with endpoints at 3, 5 and E at negative 4, 0. We'll assign the two endpoints to be x1, y1 and x2, y2. We're then going to find the x midpoint by adding the two x endpoints. x1 is 3 plus x2 is negative 4 divided by 2. 3 plus negative 4 equals negative 1 over 2. For the y midpoint, add the y coordinates 5 plus 0 divided by 2. 5 plus 0 equals 5 divided by 2. I'll write it as a coordinate point. The midpoint is at negative 1/2, 5/2. This means if you actually draw a segment on a coordinate graph, segment DE with those endpoints, this would be the midpoint. Here's a different example. This time we're given the midpoint. Our midpoint has coordinates of 3, negative 4. This becomes my midpoint for x, and this is my y midpoint value. I'll label them xm, ym. We also know one endpoint. I'll call this the first endpoint, x1, y1. We're going to be finding the coordinates of the other endpoint. So we want to find x2 and y2. I'll set up the equation exactly the same. The only difference now is I'm going to be putting in the numbers in a different place. In place of xm, put in 3 equals x1 is negative 3. The second x I don't know, divided by 2. Do the same for the y's. I know xm, I know ym. Plug in ym for the second part equals the first y is negative 1 plus the second y, don't know that yet, divided by 2. This looks like a tough algebra equation. It's very simple if we just get rid of the denominator of the 2. I'm going to multiply both sides by 2 in order to get rid of that denominator. 2's go away. 2 times 3 equals 6, equals negative 3 plus the second x. Remember that this just means placement. Add 3 to both sides to get x by itself. 9 equals the second x. Over here, I'll do the same thing with the y's. Multiply both sides by 2. The y's cancel on the right. 2 times negative 4 equals negative 8. Set that equal to negative 1 plus the second y. Add 1 to both sides to solve for the second y. Negative 7 equals the second y. I'll write my other endpoint, which will be point x, since it's segment xy, and one endpoint is already given as y. I'll write my other endpoint x as having coordinates 9, negative 7. Our next example deals with angles. First, I'll draw a picture of the situation. I have angle HJL, where JK bisects that angle. I'll label it HJL, and JK is the bisector, so I will label this ray JK. If HJL equals 42, what are the measurements of HJK and KJL? If this bisects, we divide it into 2 equal parts. That would mean each piece would be half of 42, so each one would be 21 degrees. So my measure of each angle is 21 degrees. Our next example, instead of numbers, this time we have variables with x's. We're given MO, that ray bisects angle LMN. The measures of our two congruent angles are 3x minus 20 degrees and x plus 10 degrees. We're going to solve for x, and then we'll plug in x to find the measurement of each of the two angles. I know that bisect means it divides the angle into 2 equal or 2 congruent parts. That would mean 3x minus 20 equals x plus 10. We have x's on 2 different sides of the equation. This time I need to bring the x's to one side and the non-x's to the other side. I'll subtract x from the right, so my x's end up on the left side of the equation. 3x minus x equals 2x. Bring down the negative 20. Set that equal to 10. Add 20 to both sides to get the non-x's on the other side of the equation. 2x equals 30. Divide both sides by 2. X equals 15. Plug x, 15, back into our equation. (15 plus 10, 25). 3 times 15 equals 45 minus 20, 25. They should both be the same since they're congruent angles. One final example, same as the last example. This time we're going to find angles ABD, DBC, and the entire angle ABC. It still bisects the entire angle, this ray BD. We're going to set up the equation the same since it bisects. These are equal parts. 2x plus 50 equals 5x plus 5. Solve for x. I'll bring the x's this time to the right side, just because most people like to see a positive x rather than a negative x. And we solve. This would give me 50 equals 3x plus 5. I'll bring the 5 to the left side since my x's are on the right side. 3x equals 45. Divide by 3. X equals 15. Plug that back in for x. 2 times 15 would equal 30, plus 50 would equal 80 degrees. So my first angle's measure is 80 degrees. My second angle, angle DBC, 5 times 15 would equal 75, plus 5 is once again 80. They should equal the same, the two smaller angles. Our large angle, ABC, we add the two angles together. 80 plus 80 equals 160 degrees. And that's it for our lesson for today.